In 1934, German-born physician Rudolf Schindler introduced the flexible gastroscopy clinic to the US, a breakthrough in internal diagnostics that allowed doctors to see inside the body without surgery. His clinic represented a turning point in medical technology. Tools no longer just treated, they revealed. This innovation came during the Dust Bowl and pre-Social Security era, when federal attention was turning towards standardization and organizing public health. Schindler's work reflected a new trust in mechanical vision and non-invasive insight, tools that could diagnose without harm. His clinic was also part of a wider trend. Many diagnostic facilities were religiously affiliated, framing their work as both a scientific and spiritual act of discernment, seen within the body and soul. This moment helps us trace how clinical engineers today inherit a dual mission: build systems that reveal truth accurately and ethically. Dust Bowl devastates rural America. Environmental collapse and agricultural failure compounded the ongoing economic depression, creating urgent need for medical and technological support in rural areas. These conditions highlighted the importance of scalable, adaptable diagnostic tools that could function in under-resourced settings. Social Security Act on the horizon of 1935. The nation began to lay the foundation for a formal public health safety net. This growing interest in population wide wellness reinforced the value of early detection and preventive medicine, such as gastroscopy. Amid disaster, federal agencies began channeling funds into infrastructure and health initiatives. Diagnostic innovation became more than a clinical tool, it was a symbol of state supported care, rational science, and a moral obligation to protect vulnerable lives. In 1934, Doctor Rudolf Schindler brought a European diagnostic breakthrough to American soil during a time of national hardship. His clinic represented hope through innovation, offering visibility into illness when so much else in society felt uncertain and hidden. Schindler's tool, a semi-flexible gastroscope, allowed physicians to visualize the stomach lining without surgery. This advancement was revolutionary. Minimal, invasive, it was precise and empowering for physicians and patients alike. Schindler emphasized careful handling, clear documentation, and repeatable methods. His work laid a framework not just for future diagnostics, but for engineering based approaches to human safety and bodily integrity. In essence, he made seeing within both a technical and moral act. Faith based institutions didn't resist technology, they often pioneered its use, especially when it served healing and human dignity. Schindler's tools found a home in hospitals where the mission to heal aligned with spiritual purpose. In this view, diagnostic visibility wasn't just medical, it was moral. Seeing within the body became an act of reverence, a way of stewarding the sacred vessel of life. The endoscope, like the stethoscope before it, extended the reach of care and perception. Clinics during this time were increasingly framed as liminal spaces where scientific inquiry met spiritual responsibility. The body was not merely biological, but theological, and tools that revealed it had to be wielded with humility and precision. Schindler's innovation introduced the challenge of aligning optics, lighting, and anatomy. Today's diagnostic environments build on that legacy, requiring precise calibration of imaging tools within integrated systems like PACS and EHRs. Just as Schindler's scope allowed clinicians to see within, today's engineers maintain the tools that make these internal views possible. From endoscopy to ultrasound to MRI, engineers ensure clarity, reliability, and precision, often invisibly. These systems aren't just technical, they carry deep ethical responsibility. Engineers must protect patients by safeguarding imaging accuracy, minimizing harm, and respecting the privacy of internal data. The spiritual trust once placed in clinics now extends to the tools themselves. To see inside a body safely is a miracle of both design and devotion. Clinical engineers ensure that miracle works reliably for every patient every day. At a time when exploring inside the body was still controversial, Schindler's gastroscope, paired with clinical precision, reframed internal diagnostics as both safe and scientifically rigorous. His clinic was as much a social innovation as a technical one. His work benefited from support networks that blended spiritual mission, religious hospitals, social policy, the New Deal era investment, and medical engineering. These forces made such clinics possible, acceptable, and sustainable. Today, clinical engineers inherit this legacy, designing, calibrating, and safeguarding the systems that allow us to see within. Whether imaging, monitoring, or diagnostics, the purpose remains the same: care guided by clarity. From 1900 to 1934, American healthcare transformed. Early century care was driven by moral purpose, framed by Christianity, civic duty, and national efficiency. Health became not just a biological state, but a moral reflection. Churches and religious institutions played key roles in advocating for hygiene, exams, and systemic reform. Life insurance, federal policy, and military preparedness forged the beginnings of healthcare infrastructure, often justified through theology, social science, and risk logic. Clinical engineering emerged not as a separate profession yet, but as a shadow presence in these systems, maintaining devices, supporting exams, and ensuring usability long before formal titles existed. By 1934, with Schindler's Clinic and the groundwork laid by earlier reformers, a new age of precision, visualization, and systemic accountability had begun.